Hey there guys, it's Cooper Codes. Today we're going to be taking a look at the problem Find Pivot Index on Leetcode. Let's get into it. When starting to get into this problem, it's helpful to understand what the pivot index actually is. The problem defines the pivot index as the sum of the left equal to the sum of the right. An important concept to understand is that it says strictly to the left and strictly to the right. We can understand this further by taking a look at an example from Leetcode. So this is one of the first examples in the Leetcode question, and we're given to us that the pivot index is 3. And we can kind of understand how it becomes 3. If you look at the values of the left, they all add up to 11, right? And if you look at the values of the right, they also all add up to 11. It's important to remember that you're not factoring in your current value. For example, we don't look at the current 6 we're looking at. There's different ways to attack this, so let's approach that. So if we look at this example, it's kind of easy to see how they found the pivot index, right? But when approaching this problem for the first time, it can become difficult to find where it is, right? One of the key parts of this problem is thinking about how we can find the sum of the left and the sum of the right. One of the key ways to do this is to find the sum of the entire array, and then, looping through it again, we can partition the left side and the right side as we move through it. When thinking about our left sums and our right sums, we can imagine the total sum as our entire right sum, because initially we haven't been through the array at all, so kind of imagine to the right of our pointer is the entire array. Now let's think about actually moving through the array, right? So we initially have a pointer set to the 1, right? What's going to happen to our right sum? Well, let's just say our right is initially set to 28 like it is, right? Now the values to the right of us is going to be 28 minus our current value, which is 1, right? So it's going to give us a value of 27, which represents all of these numbers. And so now let's think about our left. Our left is initially going to be set to 0, right? But what's important here is in the next step, our pointer is going to move forward, right? And we want to save that current value to our left. So let's do that here. Plus 1. Left is going to give us a value of 1, right? And so you can think about our algorithm in 3 different steps, right? The first step is to subtract the current from right, because remember we want to make sure we're also not accounting for our current value, right? So subtract our current from right, and then 2, see if sums equal, and for 3 we're going to add current to left. I didn't count this in, but at the very end we are going to move forward. Alright, so that's kind of our algorithm. Let's go through and see how our sums change with that algorithm, right? So I'm going to erase our right and left, get them back to normal. So we're going to say, okay, right's equal 28, left's equal 0, right? So now let's look at our first index, right? We have the 1, it's going to subtract 1, going to give us 27 for our right sum, right? That's subtracting the current from right. See if the sums are equal from right and left. They're not in this case. And so now we're going to add our current to left. Plus 1 is going to give us 1, right? Then we're going to move forward, same thing. We're going to do minus 7 is going to give us 20, right? And so now that we have the minus 7 is equal to 20, we're going to see if the sums are equal. They're not. 20 doesn't equal 1. So now we're going to add our 7 we got there to our left. It's going to be 8, right? And we could do this one more time to get to our 3. So now it's going to be, let's see here. It's going to be 20 minus 3 is going to give us 17, for example, right? 17 doesn't equal 8. And so now we're going to have to add 3 to our left, 11. Now here's where the magic happens, right? We're going to get our pointer to 6. And now look at this. Our 17 we had before minus 6 is going to be equal to 11, right? Now the left sum and the right sum are equal. I kind of went through that fast, so hopefully you guys can kind of follow along. This is kind of just the basic overview of the problem, and in other questions I'll probably go into summing arrays like this more in depth. Alright guys, let's get into the actual solution behind this problem in Leetcode. So, first things first, we're going to have to keep in mind that total sum we had talked about initially. One way to easily get the total sum of the array without having to loop through it in Python is saying sum and then the array names. This is going to give us pretty much adding up all the values like you would if you just looped through and had a total sum variable, right? So there we go. Now let's set our initial right value and our initial left value, right? If we think about what we had in our array, right, left's going to be initially 0, and right is initially going to be equal to the total sum, right? And so this is just kind of breaking up the problem in a way that's easy to digest, right? Now we're going to say for number in nums, right? So now we're going to go through each number like we talked about, right? And so let's look at the 3 steps we talked about in our algorithm, right? First thing is subtract the current number, right, from the right. So we say right minus equals current, right? This is going to give us the expected example as we had in our paper, right? Now we're going to see if the sums are equal. If left is equal to right. And if that's true, it wants to return an index. So you'll see I actually made a small mistake here. Instead of going for number in nums, we should say for I in range length of nums, right? Because we actually do care about the index. So that's a mistake sometimes I make in Python, and that's important, right? So now we can just set our number equal to nums of I, because that's kind of the current number we're at, right? And so it's going to be right minus equals the number, right? And so if left is equal to right, we are going to return our index, because the index we're currently at is our pivot index, right? And like we did before, we're going to add our current number to the left value, right? So now you're going to say left plus equals number, right? And if it is able to get through this entire for loop and not return I, that means that we didn't find a case where left is ever equal to right. So that's where we can have our edge case for returning -1. All right, that case passed, and we got an accepted solution. Hopefully this solution and explanation was helpful for you guys. I'm looking to do more array problems in the future, so feel free to subscribe and like the video. And make sure to comment below any Leetcode questions you might have or any questions you have specifically to this problem. I'll be for sure to answer them. All right, thanks guys. Have a good one.